I'd like to say hello to everyone who's out there listening today, and welcome to the webinar. We really would like to thank you for joining us for today's presentation. My name is Abby Bauer, and I'm an associate editor for Hoards Dairyman magazine. My co-host is Mike Hutchins from the University of Illinois, and he is working behind the scenes with Jim Baltz, who's also from the University of Illinois, and then Patty Hurchin, our online Hoards Dairyman media manager, who help us make sure everything runs smoothly each month for these presentations. This particular event is a milestone for our team, as it is the 100th webinar, which is co-produced by Hoards Dairyman and the University of Illinois. Since January 2011, we've been hosting these free monthly webinars as another way to share timely, useful information to dairy producers and those of you who are working in the dairy industry. To recognize this special production, we have a special gift to send one of our lucky listeners from today's webinar. Hoards Dairyman magazine has been in existence since 1885 when our founder, W.D. Hoard, began the publication. And then in 1899, we started the Hoards Dairyman farm with a herd of Guernseys. And today we still are milking that herd of Guernseys on our farm, which is just north of Fort Atkinson, in Wisconsin, where our office is located. Last year was an exciting year for our farm as we started producing cheese from some of our Guernsey milk. And one attendee from today's live audience will be selected after the webinar to receive a block of our Hoards Dairyman Farm Creamery Bel Air cheese. So once again, we'd like to thank you for joining us today, and we look forward to sending one of you a sample of our cheese after the presentation. We're all in for a treat today, even if you don't win the cheese, because we have the opportunity to hear from Geoff Dahl, a professor at the University of Illinois, who will share some really great research on the topic of heat stress. I know that many of us in the northern climates are feeling like heat stress is really far away right now. In fact, in Wisconsin, I was just mentioning that we're expecting 2 big snowstorms this week. So winter is definitely here, but warm weather is not that far off. And we wanted to give people a chance to learn about the heat stress and some of the long-term impacts and have time to make changes before that hot weather comes. So we're really glad to have a great audience on board today and hope that you can take away some good information from Dr. Dahl's presentation. The presentation today is titled Heat Stress Affects Dry Cows and Calves, and we'll be looking at some of those long-term impacts that heat stress could have, not only on today's cows, but future generations of their offspring. Our sponsor for today's webinar is TechMix. You'll see their logo there on the screen, and we are very, very pleased to have their support of this program. For any of you that are listening to the presentation live, you have access to the PDF copies of the slides that will be presented today. If you look at the GoToWebinar panel and you go down near the bottom, there's a section that says handouts, and right there you can click on those links and get a PDF of the presentation slides if you want to be able to take notes there. And I think that is everything that I have at the moment. So my co-host, Mike Hutchins, if you would go ahead, further introduce our speaker, and then kick off the webinar, that would be great.
Well, very good, Abby. It's my both professional and personal honor to introduce a good colleague and co-worker of mine, Dr. Geoff Dahl. Dr. Dahl grew up in Massachusetts, receiving his bachelor's degree at the University of Massachusetts. He has master's at Virginia Polytech, and then his PhD at Michigan State as well. And then he spent a few years as a postdoc at Michigan State, and then joined the staff at the University of Maryland from 1994 to 2000 at Maryland. And then we were fortunate in Illinois to have Dr. Dahl here for about 6 years, from 2000 to 2006 here at the University of Illinois. And he had several important leadership things he did here on the campus, including our online teaching program. And then in 2006, University of Florida lured him away as department head, and he has served in that capacity at the University of Florida there since 2006 and present. He currently is also got a chaired position there, the Weeks professional professional chair, professorial chair there as well. Dr. Dahl is well known for his research and teachings and extension work in animal production health, notably in the photosynthetic area or photoperiod area, and also for heat stress abatement, which is our topic for today, and covers multiple species as well. So, Dr. Dahl, we will turn the program over to you and let you have the time to go to our people online on this critical topic, calling on heat stress, as Abby mentioned, affects dry cows and calves. Dr. Dahl, the program is yours.
Thanks, Mike, and thanks, Abby, for the invitation, and thanks, Jim, for assisting with setting up these slides and getting everything technically squared away for the presentation today. So we're going to be talking about effects of heat stress during the dry period, so late gestational effects on the cow in the next lactation, and also some impacts on the calf developing in that cow late in gestation, because there are some early life effects in that animal and also some later life effects as well that you'd be interested in knowing about. So just to set the stage, I think that everybody in the audience probably is well aware of what happens when cows are heat stressed during lactation. There's an obvious decrease in dry matter intake in those animals, a reduction in milk yield, and that reduction in milk yield is actually more than we might expect just looking at that lower intake of the animals, and that's probably because there are some other adjustments that the animal makes metabolically in order to get rid of excess heat, and that pulls away from productive purposes, i.e. milk production. So we see a greater drag on milk yield even than we might expect with the drop in intake. And a lot of times the recovery from that is going to depend on how long the heat stress actually lasts, and the longer it lasts, those animals are going to have a harder time coming back to where we would have expected them to be given the lactation curve. So a lot of my career, I've worked not so much with lactating cows, but with cows during the dry period and looking at management interventions that can influence them in the next lactation. So we asked a pretty straightforward, simple question, what about dry cows and what happens when those animals are heat stressed? And so to set up the rest of our discussion today, the first thing that we're going to talk about is the dam, so the cow. And when we have her and she experiences heat stress during the last 45 to 60 days of gestation, which is typically what we're going to target for a dry period, and influences on milk and metabolism in that animal during the dry period, but also in early lactation, and also immune function, because we know that those cows are going to be immunologically challenged as great as they will be during that dry period and into the transition into lactation. And then we'll talk a little bit about the effects on the calf, the developing fetus, when she experiences heat stress because the dam is experiencing it. Early life effects on health and growth, and as that animal moves into the reproductive string, and then finally the effects on particularly cow performance of those animals in their first lactation. And now we've actually got some data looking at second and third lactation in those animals as well. So one of the reasons that we really became interested in this was some work had already been done with regard to heat stress in dry cows. And there was some information out there looking at the impact. But I think one of the sort of analyses that we did that really drove it home to us was represented in this slide. So you can see that we did a pretty simple analysis just looking at the average monthly production according to DHI records. Those are those bars there. We looked at it across 4 different years, and you see that there's a very sort of similar annual pattern. So we're going to see our highest production in Florida typically in March or April, and then we see our lowest production in September, October. And then we simply plotted that against the average high temperature for those months. And you see our high temperatures are going to occur in usually June, July, August really, and our low temperatures are typically December and January. And what it said to us was, if we look at those plots against each other, if the only effects of heat stress were in the lactating cow, then we might have expected our low production to be in June or July or August, yet it seems to have a lag of a couple of months. So that suggests that something else is going on in those cows coming into milk in the fall, particularly to create a drag on their production and obviously we think that that's probably heat stress during the dry period.
So we have our first poll here right now, and so you all get a chance to vote. So it says, is heat stress important in areas outside of southeastern United States? And we have 4 choices, and you can see never, yes, third choice maybe, and number 4 depends on global warming, and of course our wonderful president's decisions where that goes as well. So it's open. The polls are open now, and we're off and running here, and we're getting a rapid voting here. Wow, everybody must think they know what the answer is. And so Dr. Dahl, you're going to see this here right about now. We're going to close the polls. We are over 75% in, and we can see. What do you think, Dr. Dahl?
Well, I think that maybe we've been somewhat effective getting the information out to people about cows being heat stressed, even in places like those that we were discussing before, Mike, Minnesota and North Dakota and other places that are pretty chilly right now, but they're going to be hot eventually. And those cows are definitely going to end up being heat stressed. So just to sort of set the stage for our experiments that I'll be talking about, to sort of show you where we do those studies, this is our dairy for the university in Gainesville. You see that pretty, I think, common throughout the industry, throughout the country. We've got sand-bedded freestall barns, a 4-row barn. We got fans over that for heat abatement. And then you see in the foreground, kind of halfway up, those are our soakers, our feed line soakers, and that's the only place that we have soaking of our animals for heat stress abatement. Of course, the big difference from what many of you would be familiar with are that we don't have any of those things called walls or curtains on the outside. We don't typically require those. But just to give you a sense of where our animals are housed during our studies, and perhaps the relevance of that to, I think, the industry, I think it's important to set that up. Another thing to let you know is we've used all second lactation and greater animals in our studies, and we are going to target a 45-day, about a 6-week dry period in those cows. So when I talk about dry period length, that's what we're shooting for, although there's no reason to think that, and studies have been done with sort of a 60-day dry period, and you see some similar responses in those animals. So as I said, we've got sand-bedded free stalls, fans over the stalls, and soakers over the feed line. Our fans come on at about 70 degrees, and then the soakers are going to come on at about 72 degrees for 1.5 minutes every 5 minutes. So in our environment, that's going to mean that those fans and soakers are on much of the year. We've got typically time of the year when we're going to be at a THI over 68 for probably 270, 275 days out of the year. So extensive amounts of potential heat stress for our animals. And just a plug here, there's some real good information on the K-State website if you're looking at information on cooling systems and that. So I'd encourage you to take a look there if you want some specifics on cooling systems in barns. So when we look at the animals in our studies, as I said, they're all in that same barn. We implement our treatment essentially by shutting off our fans and our soakers in the groups that we want to be heat stressed. So those cows still have shade. They still have access, obviously, to sand-bedded stalls. But when we look at the relative humidity and temperature, you can see that in the absence of active cooling, those cows get hot pretty quickly, and they will stay hot for as long as they are not allowed access to active cooling. So with regard to temperatures, this is just a typical sort of run of temperatures over a 24-hour period during our studies. You see that the low temperature, 23 degrees C or so, not different because it's the same barn in the morning, and then it peaks out in the afternoon, typically up around 30 degrees C. Humidity, this is the real killer, particularly in the southeast, because it makes it that much more difficult for animals to get rid of heat. And you can see that there's no real difference in the humidity between our pens of animals that are cooled and those that are heat stressed. So the point is, we're not affecting the environment here. all we're doing in the cooling treatment is allowing animals to actively cool themselves off by getting soaked and then laying under those fans and getting that heat transfer as that water moves off their bodies. And when we start that at the beginning of the dry period, those animals become heat stressed pretty quickly. Shown here are some data from one of our studies where we were looking at rectal temperature as an indication of heat stress. In the morning, there's a difference with the heat-stressed animals being higher temp than the animals in the cooling pens, and sometimes that's statistically significant, sometimes not. It's always higher in the heat-stressed animals. We always get an increase in the afternoon that's statistically significant, and that's going to be about 0.4 of a degree Celsius on average increase in rectal temperature. And so some might say, well, that's not that much of an elevation. It's not like a febrile response that we'd get in response to some kind of a infection. And that's true, but remember that that's there all the time in these animals for essentially 45 days straight. So what that's indicating is there's never a time in that 45 days when they've actually been able to maintain a normal body temperature. They're always elevated. And what happens when cows are heat stressed for the entire dry period in the next lactation is that they make less milk. So here we have data from one of our studies just looking at 40 weeks of lactation, so essentially the entire lactation. And I think you can see pretty clearly that the cows that are heat stressed make less milk in that next lactation versus the animals that are cooled. So talking about management of the cows, once they actually come into lactation, they're all in the same pen. They're all exposed to active cooling. So it's not like we heat stress them continually into lactation. They're all fed the same diet, milked at the same times. They've all calved at the same time. So there's nothing really about the time after they've calved that would indicate a difference in terms of treatment. All of the treatment was actually occurring during that 45 days prior to calving. And this is an effect you can see that's there at the beginning of lactation, and it persists for the entire lactation. So we were interested in trying to tease out some of the mechanisms behind that in terms of how this was working. One of the first things that we always want to do, though, is make sure that we haven't just seen this once. And if we look at a number of studies that report this, and these are all the ones that I could find in the literature that sort of use the same sort of setup. When cows are heat stressed during the dry period, they make less milk in the next lactation versus those animals that have been cooled. So it's a pretty consistent response where we're going to see less milk in those animals that were heat stressed when they were dry. So as I said, we wanted to get at the mechanism of this, and if we start by looking at effects at the mammary gland level, then if you look at milk output from the gland, it's really a pretty simple equation. It's a function of the number of secretory epithelial cells that we have in that mammary gland and how hard those cells work, so their metabolic rate. And because this response is actually there at the beginning of lactation and kind of persists throughout lactation, it makes much more sense that it would be an effect on the epithelial cell number, because we know that that's sort of going to peak in early lactation and then declines. And if we look at that decline, it's very much similar shaped curve to the decline in milk yield throughout lactation. It would also indicate that there's going to be more of a permanent effect for that lactation. And in order to establish whether there's an effect on epithelial cell number, again, that's a pretty simple equation. It's going to be a function of either increasing cell growth in the mammary gland or decreasing that rate of loss of cells during lactation. And either one of these could give you then more persistency of production in those animals. So we wanted to look at that. We had animals on our 2 treatments during the dry period, and we did it by taking a series of mammary biopsies from those animals through the dry period and into early lactation to try and get at an estimate of epithelial cell number. And what we observed was that the animals, after about 3 weeks dry and about 3 weeks before they were going to calve in then, because as I said, we target about a 6-week dry period. Those that were actively cooled had much greater proliferation of mammary cells versus those animals that were heat stressed. So in the first 2 columns here, you see epithelial cells. Those are the ones that are going to be the secretory component in that next lactation. We see more of those cells in the cooled animals versus the animals that are heat stressed. Stromal cells, kind of supportive and connective tissue and other structure within the mammary gland, similar pattern. And so total number of cells was much greater from a proliferation standpoint in the cows that are cooled when they're dry versus the animals that were heat stressed. So that's pretty consistent with greater yield in that next lactation with the animals being able to cool themselves when they were dry versus the animals that were heat stressed. Of course, we had to look at the other half of the equation as well, though, and look at what was happening from cell loss perspective. And when we look at that, essentially there's no effect on the loss half of the equation. So the first 2 bars here are at that same time point I just showed you for the epithelial cells. No real difference in apoptosis or cell death during that time period for the animals that are heat stressed versus those that are cooled. There's an increase at the beginning of lactation, and that kind of seems counterintuitive, but there's a lot going on in that mammary gland early in lactation, and that's been shown in other studies and other models that we do see an increase as animals actually go through parturition, but there's no difference between the cooled and the heat stressed animals. And there's no difference about 3 weeks into lactation. So it's not like the cows that are cooled just have greater sort of capacity to maintain cells. They're losing them about the same rate. It's really that increase in total number that's occurring in the cooled cows versus the heat stressed cows that's supporting that higher level of milk output for that next lactation. So then we know that obviously the mammary gland isn't the only factor of importance here. We've looked at various aspects of metabolism in our cows, both during the dry period, and that's going to be indicated on this slide and for the next few in that sort of shaded area on the left portion of the slide. And then the open part is early lactation effects. And what we have observed is that cows, when they're heat stressed, even at a lower level of dry matter intake, when they're dry, are going to experience a drop in dry matter intake. So heat stress does reduce dry matter intake during the dry period. But after the animals calved in, and remember they're all cooled at that point, we didn't see any difference in dry matter intake early in lactation. And I emphasize early in lactation because we only go for about 6 weeks on these measurements. So eventually those animals, in order to maintain that higher level of production, are going to have to increase their intake when they were cooled relative to the animals that were heat stressed, but we just haven't followed that out that far at this point. But certainly there is an effect on dry matter intake prepartum with heat stress. And if we look at the effects on body weight, we see similar sorts of effects. The cows that were cooled during the dry period actually, and they all started out at the same body weight essentially when they dried off, but the cows that were cooled maintained or increased body weight a little bit. The cows that were heat stressed actually had a hard time maintaining body weight during that time, or at best maintained it. After calving, there is a reversal. We see that the animals that were cooled are going to lose more body weight versus the animals that were heat stressed, and that's consistent with no differences in milk production during the early lactation and the rest of lactation in those cows versus the animals that had been heat stressed. And if we showed you the figure that we've generated data that we have for body condition score, you'd see a very similar pattern. So it appears that just like we'd expect, those cows that have been cooled when they were dry are actually making more milk. There's no real difference in intake, and so they're mobilizing greater amounts of reserved tissue in order to support that energetic output. So in terms of some other measurements of metabolic capacity in those animals, when we look at For the most part, we don't see differences in circulating insulin when the animals are heat stressed during the dry period, no change in blood glucose. We don't really see any change in NEFA in those animals or non-esterified fatty acids, except when we get right to calving. So this is a little different from what you might be familiar with heat stress effects, particularly in lactating cows. But we've done this, and we've done insulin and glucose challenges as well. We just don't see much of an effect or direct effect of heat stress during the dry period on those indices, but we do see effects early in lactation. For example, those animals that were cooled have greater mobilization and NEFA early in lactation versus the animals that were heat stressed. And we think that that's just consistent with the higher level of milk output in those animals versus the animals that were heat stressed during the dry period. So the next thing that we wanted to examine was the impacts of these treatments on immune function, because if there's one thing we don't want to do, it's get higher productivity at the expense of immune status in the animals, particularly around the time of parturition. So we've looked at this in a number of ways. One of the first ways was kind of a gold standard from a test tube perspective in terms of immune status, looking at lymphocyte or white blood cell proliferation. This is during the dry period, so when the animals were actually heat stressed. And what we observed is that the animals that are under heat stress actually have a lower proliferative rate versus the animals that were cooled during that time. We've also looked at some other aspects of acquired immunity. In particular, this one was looking at the response to an innocuous antigen, so just vaccinating animals with chicken egg white and looking at their response to that foreign protein. See, the animals that are heat stressed have a lower response to each of the booster injections that we gave them during the dry period when they were heat stressed versus the animals that were cooled. There's no difference once the animals calve in, so they're all cooled at that point. So we'd attribute this to a direct effect of the heat stress on those animals' ability to generate an immune response. And I think that from a practical standpoint, that's probably got some implications when we think about the protocols and the vaccination protocols that we use on dry cows. When they are dry, we want to enhance that and get it to as good a response as possible. And that's probably going to mean that we want them cooled rather than heat stressed. And then shifting over to innate aspects of immune function, neutrophil activity. Here's where we saw a little bit of a difference from our acquired immune system. We see that there's no real effect during the dry period on neutrophil activity in terms of the phagocytosis, which is in the lower panel, and that's the ability of neutrophils to actually find a pathogen and engulf it. Oxidative burst, that's how they kill those engulfed pathogens. Neither of those change between heat-stressed and cooled cows during the dry period, but early in lactation, the animals that had been cooled actually had a more robust response versus the animals that were heat-stressed. So even though they're all cooled at that time, the animals that were heat stressed when they were dry seem to have some carryover remnants here so that they have less ability to mount a response versus the animals that were cooled during the dry period. And we've repeated this study and shown the same types of responses. So definitely some implications there on early lactation disease incidence. So in terms of looking at things like disease and milk yield, reproductive performance, difficult to do that in a controlled setting with the number of cows that we actually need, and difficult to get a producer to agree to actually implement that when we're showing them data that says that if we heat stress 300 or 400 of his cows when they're dry, they're going to make a lot less milk in the next lactation, probably have some lingering effects from a disease standpoint, and possibly have poor reproduction. So we took a little bit different approach with that. We looked at records of cows on a commercial farm, very consistent, high-level management on that farm, but they were essentially putting all their dry cows outside. So this is in Florida. The animals that were outside during June, July, and August had limited access to shade. So those animals were going to be hot. The animals that were dry during the cooler months of the year, December, January, and February, they were going to be obviously in much better environmental conditions. So we just looked at their records to try and see if we could tease out any indications support for our controlled studies. And when we look at the first up on the top line there, you'll see that when cows have their entire dry period in Florida during June, July, and August, in that next lactation, they made about 600 liters less milk versus the animals that had their entire dry period during December, January, and February. So significant reduction in milk yield in the cows that were dry during the hotter months versus those that were dry during the cooler months. And then in terms of disease, mastitis, greater incidence in the cows dry during the hot months, respiratory disease, retained membranes, although that didn't translate into metritis. I think partially because they've got such a good management system in place, they actually have limited metritis there, but it just indicates that those cows are immune challenged potentially when they're dry during the hotter months of the year versus those that were dry during the cooler months of the year. The only place where we saw more disease incidence in the cows that were dry during the coolest months of the year was digestive disease. And that's going to include the incidence of ketosis. So I think that probably we see a little bit more of that in our cows that are dry during the cooler months of the year. They're also making more milk. So that's going to be consistent with that. And certainly it didn't limit their ability to overcome other diseases or make more milk. So I think we can manage through that pretty effectively. So then in terms of reproductive performance, a little bit smaller number of animals here just because we truncated it at the first 150 days of milk, but still a reasonable number of records to look at this. Milk production differences are still there in this subset of our data. In terms of number of breedings to get cows pregnant, greater in the cows that were dry during the hotter months of the year versus those dry during the cool months of the year. Days in milk to breeding was longer in those animals dry during the hot months, and just stands to reason then days in milk to pregnancy would be greater as well. And one thing to remember is that all of this is in the face of some acute challenges that our cows that are dry during the cooler months would have, because we were trying to get them bred during the hotter months of the year, and we know that that's going to have some relatively short-term impacts on reproductive performance. The fact that they are still showing improved reproductive performance is indicating that they're better off than the cows that were dry during the hotter months of the year. So one question that comes up quite frequently is how much of the dry period do we need to cool cows for? Can we just do it for the close-up phase? And so we've done a recent study to address that and look at that. And this sets up what we looked at first was just to confirm that we're seeing our heat stress effects. So the two left panels there are rectal temperature and respiration rate in cows that were dried off and exposed to either our cooling or our heat stress treatment, and that's for the first 3 weeks of the dry period. So the animals that were heat stressed, higher rectal temperature as expected, higher respiration rate. So at the 3-week mark in the dry period, we took half of each of those groups and we put them to the other treatment. And that's what the two right-hand panels represent. So we've now got 4 treatment groups: cows that were cool for the entire dry period, cows that were heat stressed for the entire dry period, the cows that were cooled for the first 3 weeks and then heat stressed for the last 3 weeks of the dry period, and the similar switch cows that were heat stressed the first 3 weeks and then cooled for the last 3 weeks of the dry period in order to get at some of these responses. And we see that the rectal temperature and respiration rate goes right along with whatever the treatment of those animals is during that time period. So heat stress increases rectal temperature and respiration rate. So one area from a mechanistic standpoint that we think is probably having a major influence here is the effect of placental function in these animals. And we know that cows that are heat stressed when they're dry or during late gestation are going to have a reduction in gestation length and in turn dry period length. And we've observed that in previous studies, and I think that this is giving us some insight into some of the responses that we see from a milk production standpoint, just because of the effects of placental hormone output and other factors on mammary development during that dry period. And what we observed in these 4 groups of animals was that our cooled cows, when they were cooled the entire dry period, had longer gestation length and therefore longer dry period length than the cows that were heat stressed for the entire time. But when we look at our 2 switch groups, they're not different from the animals that were heat stressed, but they are less than the animals that were cooled for the entire dry period. So there's no real difference between either of our 2 switch groups and the animals that were heat stressed for the entire dry period with regard to gestation length or dry period length. And we think that's probably part of the reason why we see the responses that we do with regard to milk production in that next lactation, which is illustrated on this slide. So if we look at that top blue line, that's a dashed line, versus the orange line that's in dots, we see our normal sort of response of cows cooled for the entire dry period versus those animals that were heat stressed for the entire dry period. And that was about 4 liters a day less milk in the cows that were heat stressed for the entire dry period. Our 2 groups in between there, the solid lines, are the switch groups, and there's no difference between those 2 groups of animals. It looked like early on we might see a little bit of an increase or recovery with some dry period cooling, but really it turned out to be not the case. So there's really no difference at all between the animals that were in either of the switch groups with regard to milk production from the animals that were heat stressed for the entire dry period. And they're all below the production of the animals that were cooled for the entire dry period. So that suggests that we need to make sure that we're getting cows cooled for the entire dry period in order to see these responses and these persistent responses.
Well, we have another poll question, so Dr. Dahl, you can rest your voice there for just a minute, and Abby, get ready to vote here. The question is, how much of the dry period do cows need to be cooled to see milk responses? And so the choices here are the entire dry period, the last 3 weeks, the first 3 weeks, last month, or gee, that's a good question, and I give up. So, Abby, do you have an answer?
Mm-hmm. Well, Mike, I think it is a good question. My hunch would be that the last 3 weeks are the most important, but I think to be safe, I would say the entire dry period would be the most beneficial for milk production. What do you think, Mike?
Yeah, I'm going to vote with you as well at this point. And anyway, Jim's closing it. And Dr. Dahl, do you want to make a comment on the votes here today? We had about, again, 66% of people responded.
Yep, looks like people were good at short-term retention. I think that's what our data show, that we want to cool those cows for the entire dry period in order to see this response in that next lactation. So, tight on time, Mike? So you're telling me I need to make sure I'm at Hutchins speed in terms of my delivery. Okay, we'll sort of skip through this one since it's really just a summary of what we're seeing in those dry cows, less milk in the next lactation, reduced immune status in those animals as well, and shift our gears now to look at what's happening in those calves in their that have gestated in heat-stressed animals or not heat-stressed animals. As I said before, we see a reduction in gestation length in cows that are heat-stressed during late gestation, and that means that calves are born a few days earlier, and that means that they're born at a lighter weight That's part of it, certainly, but it's also the effects, as I said, on placental function overall being challenged in those cows when they're heat stressed versus the cows that are cooled. And that shows up in birth weight. This has been shown plenty of times before, but we wanted to confirm it, obviously, in our model that cows that are born to heat stress dams lower birth weight than cows that are born to cooled dams. We've extended that out now to look at weaning weight as well, and we see that that persists through weaning. The heat calves that were born to the heat stress dams, lighter weaning weight than the animals that were born to the cooled dams, and it's not really an effect on body weight change so much in terms of overall growth, but more of a persistency effect of that lower birth weight. One area that was specifically of interest to us was the effects on immune status in the calves as well. And so we looked at this in one of our earlier studies, just sort of a quick look, really, is what it started out as. We measured total IgG in circulation in those calves that were born to either cooled or heat stress dams, and we actually calculated the apparent efficiency of immunoglobulin absorption in those animals. And what we observed was the calves that were born to the cooled dams had higher Ig in circulation and improved apparent efficiency of absorption as well. And so those animals actually had, we would interpret that as higher immune status early in life when they were born to cool dams versus animals being born to heat stress dams. Now, one thing that came obviously to mind was there an effect on colostrum? And if we look at total Ig content, not really an indication of an effect of immunoglobulin content in the cooled animals versus the heat stressed animals. But there could be other factors in that colostrum that could be influencing Ig uptake. And that was really the limitation of our interpretation with this study, because in this one, all of these calves got colostrum from their dams, and these calves got colostrum from their dams. So probably not so much of an effect on total Ig exposure, but certainly they had reduced Ig uptake. So we wanted to set up a study to really look at that more closely. 2 experiments were done. We wanted to tease out whether this was a calf effect or a colostrum effect. So in our first study, we had animals, calves that were born to heat stress cows and calves that were born to cooled cows. And then they were all fed from the same pool of colostrum. So we just created another pool of good quality colostrum, and it was independent of these cows and this group of cooled cows. And we fed that to those calves and then looked at the transfer in those animals. And then we saved the colostrum that the heat stress cows produced, and we saved the colostrum that our cooled cows produced, and we made 2 other pools of colostrum. So we fed this heat stress colostrum to calves that were born under cooler conditions, and we fed the colostrum from our cooled calves to cooled cows to a group of calves born at the same time, in order to split out whether this was an effect on the calf or an effect of the colostrum to influence Ig absorption. So in terms of the first study, when we look at that, we see that the animals that were born to the heat stress dams, lighter body weight early on, and that persisted through weaning, just as we'd observed previously. We also started to get some indication of what type of growth that was, whether it was lean growth or not. And in fact, it appears to be, and we have some other information with other studies to really support that the calves that are born to cooled dams, they're taller at about 2 weeks of age, and that persists through weaning. So that's an indication, at least at the gross level, of greater lean growth in those animals versus the animals that were heat stressed during late gestation, and that may have some implications for the productivity of those animals later in life. And when we looked at apparent efficiency of absorption, we saw the same thing that we had seen previously. Calves that are born to cooled dams, higher apparent efficiency of Ig absorption versus the animals that were born to heat stress dams. And yet they all got colostrum from the same source. So it was all fed at the same time after calving. It was all the same amount. We tubed the animals. We know they got what we said they got. So this would suggest that there's an effect on the calf, limiting their ability to absorb IG versus the animals that were born to cooled dams. We had to do the second study, though, obviously, to confirm that. And here are some of the growth responses in those animals. No difference in birth weight. As I said, they were all born at thermoneutral times of the year, so we didn't expect there to be. There's no effect on any of the growth variables that we measured. And in fact, we didn't expect there to be. And further, when we looked at the immunoglobulin absorption or the apparent efficiency of absorption, there was no difference between the two groups of calves, despite having colostrum from either heat stress dams or cooled dams. So that really suggests it's an effect on the calf rather than an effect on colostrum, which from an application standpoint means it's probably going to be a little more difficult to overcome without getting those cows cooled during late gestation. And in fact, we've gone on to look at this a little more closely in terms of the mechanism, and it appears to be that the calves that are born to heat stress dams actually have an acceleration of gut closure, and that's just an indication of cell loss in the intestine early in life. And we see that gut closure appears to be related to that epithelial cell loss along the intestinal lining. And that's accelerated in the calves that are born to heat stress dams versus those born to cooled dams. And that's probably why those animals have less IG absorption. So in terms of summary, those calves that are born to cooled dams, higher birth weight and weight at weaning. Heat stress in utero reduces immune status. It's not an effect on colostrum quality. It's an effect on the calf. And some other studies and a little bit of what I showed you from a growth response indicates that those calves that are born to heat stress dams are probably going to have less lean mass accretion versus the animals born to cooled dams. So we wanted to look at some downstream effects in terms of calf survival and productivity long-term in these animals in order to get enough indications, enough records for that. We had to combine information from a number of studies. Our calves born at the university dairy, we have a good idea of how those animals are managed. It's very consistent, and so we were pretty comfortable combining records across years from those animals. And all the animals from these studies would have been managed in very similar conditions. So we did a retrospective analysis from these 5 studies, the calves born to the cows in these 5 studies, and ended up with about 150 total records. Certainly we used some of the data from the bulls early in life, but really what we were interested in was the effects on the heifers. They're pretty well balanced in terms of calves from the heat stress versus the cooled animals. And so we were pretty comfortable in looking at what was happening in those animals long term. First thing to confirm was the effect on birth weight. And in fact, when we looked at this larger data set combining all of the other studies, heat stress during late gestation reduces birth weight versus those animals that are cooled. And there was also a gender effect, which just indicates that the bulls are born heavier than heifers, regardless of whether they're heat stressed or not. So nothing really too surprising there, but good to have that early indication that our data was consistent with what had been seen previously. Then we followed growth out in those heifers, obviously beyond weaning. So birth weight lower in the animals born to heat stress dams versus the cooled dams. Weaning weight lower in those animals as well. And in fact, puberty or about a year of age, the animals were maintaining a lower body weight as well when they had been born to a heat stress dam a year before versus the animals that were born to cooled dams. We also looked at calf survival, and if you look at this table here, we've got just so that I can clarify some things. We've got AI and IVF. That's really why we were seeing those differences that you might have picked up on earlier in terms of gender across the study. We had more heifers than bulls. That was because we were doing some sex semen studies at the same time, but they were balanced across our 2 treatments. So we're pretty comfortable in looking at records of all those animals. So the calves that were born to cooled dams, let's focus in on those animals leaving the herd before puberty. And the reasons for that, for the most part, were sickness. We see many fewer of those animals leaving the herd early on versus the calves that were born to heat stress dams. So significantly fewer of those animals then actually make it through their first lactation when they're born to a heat stress dam versus those animals born to a cooled dam. So we're seeing some effect downstream of what we were talking about with regard to immune status of those animals actually surviving in the herd. When we look at reproduction, obviously very small numbers here, but all seem to be pointing in the same direction. When calves are born to cooled dams, they have improved reproductive performance relative to those animals that were born to heat stress dams. We saw that there were fewer services to get them pregnant. They got pregnant a little bit earlier, probably lost another pregnancy or two because of that earlier settling. But overall, there was no difference in age at calving, but everything is more from a positive perspective in terms of calves born to cooled dams versus those born to heat stress dams. And then we looked at first lactation yield in these two groups of animals, and we see some pretty dramatic effects. So this is the first lactation data from the calves that were born 2 years earlier to cows that were cooled for their entire dry period versus animals that were born 2 years earlier to cows that were heat stressed for their entire dry period. So about a 10-pound-a-day loss of production for that entire first lactation just with heat stress during late gestation. So first question comes up, were the animals genetically similar? They were. It was kind of a random assignment from all these studies, so we didn't really have any differences or expect any differences in terms of genetic makeup. The next question that we thought of was, well, perhaps these calves that were born to heat stress dams, we know they're lighter at weight at birth, at weaning, at a year of age. We know there's a relationship of calving weight with first lactation yield. So perhaps these animals were at a lighter weight when they calved in, and some of this lower production is going to be reflecting compensatory gain in that first lactation, and they might do better in the second lactation and beyond. So we looked at body weight, and what we found was that didn't affect it, because even though they were different at a year of age in terms of body weight, there was no difference in the calving weight of the two groups of animals, and in fact, no difference in body weight all the way through that first lactation. So that's really not explaining the differences that we see. We've subsequently gone on to show that those calves that were born to heat stress dams have lower performance in the second lactation, in the third lactation, and all indications are that their offspring carry that effect. So what we're seeing is an epigenetic effect or a programming effect on those calves when they're heat stressed during late gestation to be less productive than the calves that were born to the cooled dams. So we've got another question now, poll question.
Yeah, we're off and running. This could go pretty quickly. Do calves from heat stress dams ever catch up in milk yield to herd mates born to cooled dams? And we have 4 choices. Yes, no, depends. Only on odd years. Abby, you want to vote on this?
My vote is going to be no, they don't catch up.
Okay. It's interesting. We've got about half the votes in, and I think, Jim, because we're going to be tight on time, let's close it off and show Dr. Dahl what we got. We got 60% of the vote here, so pretty interesting. And any surprises there, Dr. Dahl?
Well, I guess the surprise would be that, really, I think the no's are right, and it's a little low from my perspective. Really, I don't think it depends on anything. Those calves are going to be challenged when they're heat stressed in utero to be productive through their first, second, third lactation. So I would say they probably are never going to catch up. All right, so just to summarize then, when we're looking at the effects of heat stress in that dry cow, none of the outcomes are positive. either on the cow in that next lactation where she has challenges in terms of mammary growth and less productivity, and also on the immune system. And early life effects are negative in their calves when they're heat stressed during late gestation. And those calves are eventually going to go on to be less productive herd mates to calves that were gestated under cooler conditions. So nothing positive about cows being heat stressed during the dry period. So with that, I just want to thank folks that actually do most of the work on this, or all of the work on this, grad students that were involved in various aspects of the study, and my collaborator, Amanda Laporta, on some of the more recent work that we've done, and then funding from NSF, USDA, and Fibro for some studies that I didn't really present any of that data today, but certainly if you have questions, we can talk about it a little bit. So thank you, Mike. Thank you, Jim. Thanks, Abby. And that's all I have.
Okay, Abby, we'll let you kind of start before wind up some things before we go to the Q&A.
Yes, thanks, Mike. Thank you, Dr. Dahl, for sharing that extensive research that you and your team have done at the University of Florida. It's kind of unique research that's not being done a lot of places, and definitely very, very telling. The benefits of cooling cows during the dry period sure are relevant. So thank you for that. Also, once again, thank you to TechMix for sponsoring this program. We really appreciate the support that they have provided us so that we can prepare these presentations for all of you in the audience. If you want to listen to this webinar again or share it with anyone else, or take a look at any of our previous webinars, you can do that by visiting our website and going to hoards.com/webinars page, and you'll find them all there. If we go ahead, we can see the upcoming slide, or the upcoming webinars on this slide. Next month, we have kind of a unique presentation. We have a Wisconsin dairy producer, Brian Schilling, and his veterinarian, BJ Jones, and they'll be talking about some of the strategies that they have put into place in their herd to have reproductive success year after year. So if you want to learn a little bit about the reproductive program on Schilling Farms, please make plans to join us next month, March 11th, in 2019. And then also looking forward to the next month, April 8th, we will be talking about milking equipment and research done by Michigan State University Extension Specialists Phil Durst and Stan Moore, and what they've learned from evaluating milking procedures and milking equipment on dairy farms in Michigan. So please keep these dates on your calendar and make plans to attend. For all of you in the audience, we just want to let you know that you can submit questions ahead of time or during the webinar using the go-to panel that is on the side of your screen. And we did have a few questions that came in, so I will let Mike go through those, and Dr. Dahl will ask you to answer those questions at this time.
You bet, Dr. Dahl. We'll be kind of in the speed round because, man, you got questions coming out of your ears over here. This one came in from one of our foreign attendees, and that is, what is the most important changes that should be made to the ration, especially for high-yielding cows during times of heat stress? And then tied to that is, what type of fats would be preferable to use under such conditions?
Well, I'm going to defer a little bit to you, Mike, as the nutritionist online. But my experience is, I think that from most of those studies where fat has been included in some of those rations to increase their density, we typically are going to see a further drop in intake. So I don't know that we really can get away from it. We just want to have as, effective a ration as we can for those animals, so that we keep dry matter intake as high as we possibly can, and maybe focus on some of the other things to get those cows cooled off rather than trying to do it through the ration.
The only thing I would add to that, Geoff, is I would certainly watch for a positive DCAD. I think the work out of Maryland and other places look pretty positive. So a positive DCAD, and they're usually looking up around 400, a plus 400 DCAD per kilogram of dry matter. And probably if I was going to put fat in, and I know your point is well taken, Geoff, I'd be looking at probably more of the inert fats and saturated fats that would not run any risk of causing a problem out there in the rumen. We move on then to another question that comes from the Netherlands, another one of our good listeners. Could I use niacin during the dry period like it's done for lactating cows, or what do you recommend feeding during the dry period?
Yeah, I think niacin, has shown some reasonable responses from the data that I've seen. Mike, what I have been challenged by is it economically practical to actually include niacin in those rations? We've done some work, as you saw from some of the sponsorship of our studies with product from Fibro, and that has shown some pretty good responses just in terms of allowing cows to deal with heat stress better. And I'd say that that's not just our data. There's 2 or 3 other labs that have shown the exact same thing. So you may want to look at some of those other additives.
Exactly right, Geoff. And I know the niacin is going to probably be rumen protected. I know there are several companies now making that. And so you're going to be looking at rumen protected niacin to try to get maybe some kickback on that as well. Okay, well, let's go to our other questions. And here we go. Is there any relationship between heat stress and body composition in ruminants? There is some data from chicken and pigs that indicate more fatty body or fat deposition. Any thoughts on that, Dr. Dahl?
Yeah, we actually have studies lined up to look at that specifically based on some of the work that I mentioned that we've done already. Just from a gross perspective, it certainly looks like those calves that are born to heat stress dams are going to have greater propensity to put on fat versus lean growth. So we'll be able to share that with you hopefully in a couple of years to let you know. But my gut would tell me that, yeah, you're probably going to have a leaner animal when she's born to a cool dam than a heat stress dam.
Okay, and another one has to do with fan itself. What do you think of the basket fan versus the large fans that are attached up higher up in the barn roof as far as that goes, as far as cooling effects on cows?
Yeah, well, I think that most of those ones that are forcing air down on the cows probably not as effective. We want to move air across the animals as effectively and efficiently as we can. I think that website that I pointed out earlier in terms of system design for cooling system is really where people want to go to look at airspeed and other recommendations to move air across animals rather than pushing it down on them.
Here's an interesting question, Geoff, for you to wrangle on. I'm not sure if your data would suggest this, but he said if you cool cows and lose more body weight and body condition score after calving, how come fertility improves? Previous studies would argue that this is contrary to that trend. Your thoughts on that?
Yeah, well, we had sort of similar thoughts, and I guess that what I keep coming back to is that it's the question of what's the healthier cow. And I think some of that comes back to whether cows that are managing that transition, even with a somewhat higher level of, for example, NEFA mobilization versus the animals that are not, are healthy or unhealthy. I think that's a normal physiologic response. And if the cow is in a good shape to be able to handle that, overall, she should be in better shape from a reproductive standpoint as well. And so that's the only thing that I keep coming back to is that overall, even though those cows, there may be some indications of a pathology, it's really just not a pathology in those cows because it's just part of their normal physiology. And by cooling them, we actually improve their capacity to express that.
I think you got it right, Dr. Dahl. Next question is what effect on colostrum quality versus quantity on the cooled cows versus the heat stress cows?
Yeah, well, that's what I was trying to say. In terms of the actual IG content, it's at or higher in the cows that were heat stressed versus those that are cooled. They don't make as much. We don't get as much colostrum from them. So I think that's probably a bit of a dilution effect in those animals. But if we're only looking at IG content, there really doesn't seem to be an indication that those animals are at a lower quality of colostrum overall, but it's certainly getting that volume of colostrum to those animals when they are born to heat stress calves. It's going to be, or cows, it's going to be important. But even then, they're challenged when they get the same volume to absorb as much IG.
This question, I'm not sure I can help you with. Maybe you can answer. It's the initials SPC. SPC for heifers is 2.5. However, cows is 1.5. Is this due to sex semen? I'm not even sure what SPC is here, Dr. Dahl. Can you handle that?
I'm not sure.
Services per conception. Jim is typing it in.
Okay, so it was, I believe in our experience, it was lower in the calves that were born to the cooled dams versus those born to the heat stress dams, which would, that's a really small data set. I realize that, but that's an indication that those animals have poor reproductive performance.
Okay. Next question is, did you look at calves of the calves from the original heat stress cows? In other words, does this effect just multiply?
Yeah, so we have now started to collect data on those animals, and in fact, that's what I was indicating, that not only do those calves have problems through their first 3 lactations, we look at the next couple of generations, and obviously we, small numbers at this point, but significant effects in those animals as well. So that's really, that transgenerational aspect of the response is one of the things that's suggesting it's an epigenetic effect. So we're not affecting the actual coding sequence of DNA, but we're certainly affecting its expression.
Now, here's the bad news. You're actually losing ground here, Dr. Dahl. You're getting more questions faster than you're answering them. But with dystocia and primiparous cows, we need lower body weights. So does that mean we don't have to worry much about cooling because we have smaller calves? So we won't have much calving difficulty with these smaller calves under heat stress. I think I know the answer to that.
Yeah, somebody's always trying to find the silver lining in that dark cloud, and I suspect that that's one way that we can deal with dystocia, but it's not a way I would choose to.
Just an observation of the data. The question is, days in milk to first breeding in both groups was above 90 days. Is this due to a longer voluntary waiting period or in the herd? Any comments on that?
Yeah, that's what that would have been, because they are all time breeding on those animals.
Okay. We now have a little bit longer question. I use soakers with fans for cooling, but we have a problem with lameness as the cows most of the time is standing under the soaker. When we change from the when we change for the mist over the stalls, production improved and lameness decreased. So misting versus soaking and concerns about lameness. Comments, Dr. Dahl.
Yeah, not sure where that farm actually would be located. We are not able to use misting in our high humidity environment. We have to get those cows soaked in order to get good cooling. So the problem with that is if we're soaking over the stalls, obviously we're going to have wet stalls then, and we don't want that. So I think that that's somewhat dependent on the environment that folks are actually going to be in as to whether they can take advantage of that misting or not. We do not see differences in our animals in terms of lameness. They will go up to those feed line, they'll eat, they'll get up and get soaked at times and come back and lay down in the stalls.
And this would be in Egypt and Pakistan, if that changes your answer at all. The person asking the question is from most countries.
Yeah, I think it's going to be a challenge. I mean, those are probably a little bit more arid from my understanding, but we still got to get those cows wet in order to get effective cooling.
Yep, I hear you. The question is, how can we determine the effective cooling system we can use on open systems? I assume yours would be considered an open system.
I think they may be talking about feed lots, more of a open lot, dry lot environment. And what I've seen used pretty effectively, number of situations in Mexico, also in California, is sort of bringing animals up to a soaking pen. Particularly, that's going to look like a holding pen in many cases. Bringing animals up a few times a day from those external pens to get them soaked on, and then they're going to go back to those pens, and obviously that'll cool them down as much as we can, applying water to those cows to give them a chance to soak and get cool.
Any guidelines on the frequency you would need to bring them to a cooling pen? Every 3 hours, every 6 hours? Any thoughts on that, Dr. Dahl?
Well, I think that the folks that I've seen do it between 2 and 4 times a day. That's typically going to be all that they can manage, along with using that as a holding pen for the parlor. So, again, the more frequency, the better cooling, the better effect you're going to get.
Could you have a cooling pen other than the milking parlor itself? A different structure? Have you thought about that?
Absolutely. And at least one facility, that's what they were planning to do, is just put a pen up that they were going to cool the cows and then move them on through. It's going to be probably an optimum. So we don't want to be moving those cows from a dry lot 6-8 times a day in order to get them cooled off even more, because that's going to disrupt the other activities that they got, particularly lying time.
Do you think these effects are similar to other breeds? You are using primarily Holsteins here?
Yeah, I can't envision a terribly heat-resistant breed among the major breeds. We do have obviously some of the slick genetics in our herd at Florida. None of those animals would have been in these studies. Those animals are more thermotolerant, but in terms of Jerseys, Guernseys, Ayrshires, the main group out there, Swiss, I don't think that they're going to suddenly be significantly more heat tolerant.
I think you can answer this one quickly. Any thoughts on downstream effects of heat stress in the first part, gestation versus late lactation? Or another way to do it is if we get them cooled off in the first 100 days, do you think we can carry that? We've set the curve now, and these cows will keep that same 4-liter differential.
No, I think that, at a certain extent, that's who do we want to cool on the farm. And if I get asked which one group I can cool, it's going to be the dry cows because of that persistency of response. Then it's going to be the early lactation cows. And then, if I have to forego cooling in a group of animals, it's going to be kind of later in lactation, those animals.
Well, we got 2 feed questions. I'll let you take a shot at them first. Do we need to formulate a denser ration for hotter months to provide required nutrients with a smaller amount of dry matter being consumed?
Well, I guess it would come back to that fat question, and you're going to be better able to answer this than I am, but I don't envision a spot where we're going to get some magical formula that is going to allow for a level of intake we'd want, and those animals if they're heat stressed.
Yeah, and I guess I just add to that, Dr. Dahl, we certainly want to make sure our proteins and minerals, if that's going to be a factor coming in, especially for animal health, that we may want to look at bouncing them up. But you're spot on, I tell you, in terms of you got to be careful with the energy dynamics and fats and those kinds of things as far as that goes. And finally, here's your last question, sir, and then you're done. Are there some feed additives that can decrease heat stress impact?
Well, as I told you, I mean, we've done some work with Omnigen, and that seems to have an influence. There are other ones that folks say they have done studies and shown some responses. I go back to data. I want to see published indications of that. So that's where I would suggest people go is look for there are some data out there to show that there are responses to some of these additives.
Yeah, and I think I think the rumen is always a little bit vulnerable because because of the circulation of the blood. The rumen, much like the reproductive tract, can be at a little bit of a risk. So some of those rumen modifiers would be ones that I would add to the list as well, and that could be some of the buffers and decaf products and stuff like that. So, Dr. Dahl, you've done yeoman's job. Abby, we'll turn it back to you to wrap her up.
Thank you. Dr. Dahl, once again, thank you for that presentation and for answering that whole group of questions. You did a great job, and we're grateful to have you as part of our presentation today. And also want to give one more thank you to TechMix for their financial support of the webinar. If you want to learn more about them, check them out online. You see their logo there on the screen. Last but not least, I would like to thank all of you out in the audience. Thank you for joining us for this, which was our 100th webinar. As I mentioned at the beginning of the program, after the webinar, we will draw one attendee who is part of the live presentation and be sending you some of our Hoards Dairyman Farm Creamery Bel Air cheese. If any of you are interested to learn a little bit more about our cheese, feel free to look us up online. You can find us at the website hoardscreamery.com. But one of you out there will receive a free sample of that cheese for participating today. As always, we want to share valuable information with you, whether you're a dairy producer or a consultant in the industry. So we are really glad that you joined us today, and I hope that you'll make plans to attend one of our future webinars. Always take place on the second Monday of each month at noon Central Time. And we will see you in March, hopefully. So until next time, I'd like to say goodbye to all of you out there in the audience from us here at Hoards Dairyman and the University of Illinois. It is our pleasure to have you as part of this, our 100th webinar celebration. Thanks, and hope to see you next time.